Alright, now let's have a look to 4.22. Okay, integration of inverse trigonometry function. I don't know, but I think if you understand how to differentiate it, for the integration of inverse function, it is much more simple. Okay, much more simple than you thought. Okay, before I go further into example 4.10, okay, this is the formula. It will be given during final exam. You can see that this is the arc sign. You may get confused because this formula start with the integration process here, but basically it is the same thing. So previously we know that we only refer to arc sine x. Okay, actually there is it's supposed to be, if you want to understand this formula here in this table, okay, it is actually referring to arc sine x over a. So our previous example, okay, the a here is actually 1, so that is y, so x over 1, so this is it, this one becoming 1 squared, or 1 squared is equals to 1 minus x squared. Okay, and the same goes, the same applies to other inverse trigonometric functions. Okay, and you can refer that we have so this is 1 2 3 4 5 6, yep, 6 altogether. With the inverse hyperbolic functions is not coming out in our this time around, so you only need to understand up until this year. Okay, now let's see example 4.10. So you need to integrate 1 over 49 minus x squared square root dx. Okay, if you look closely, this one, which formula that you need to apply? Okay, so there is a square root, and then here we have 49. 49 obviously is a. No, it's not an a, it's a squared. All right, so minus x squared, so minus x squared. So we know that this question is actually referring to the arc sine x over a. So what you need to do is that you need to identify what is the square root for 49. Okay, so we have here a squared equals to 49. It means that a is equals to square root of 49 is 7. So that is why you just plug in into the formula here. So we have we know that it is similar to arc sine x over a. So our a is actually over 7. So plus c, yeah. So this is how we can get the final answer. So the proper way is to follow these steps. Okay, you probably can show this one too. So just to convince me that you actually understand that. Okay, all right, so we go to the second example. We go to this one. Find the integral of 1 over x times square root 25x squared minus 4 dx. So the solution, how to find the solution for this, we go back to this formula and try to look which solution is very similar to it. So we need something, yeah, this one got x, so that it will match with this question. Then what else we do need to know? This has 25x squared. Okay, we have both here, x squared and minus 4 or minus a squared. Only that this original question doesn't has negative in front of it, so definitely it's not arc cosecant, it's actually arc secant, so we will use this one. Again, okay, you need to look into the final answer. So the final answer for the arc secant is not arc secant alone, it is actually okay, it is actually 1 over a secant arc secant x over a plus c. Okay, now from here, okay, we need to get to know that we have this 25 and 4, so we probably need to find the square root for it. So from here we know that 25x squared is 25x squared is actually 5x squared, and the a is 4, s squared is 4, so a will become 2. Okay, so you need to write it down in the form of the formula here. So it will become x 5x squared minus 2 squared, okay, square root dx. And then from here, okay, what you need to do is that this is quite tricky. Okay, so you need to find the u is equals to 5x, therefore du over dx is 5. Okay, and then we write down 1 over 5 du equals to dx. Our x here will become u over 5. Now, so from here, okay, from here we will change it to u-substitution. So our dx here has become 1 over 5 du, so 1 over 5 integration of du, then 1 is here. Our x is u over 5, this is u over 5, and then here we have 5x squared minus 2 squared. Alright, so from here, okay, so from here, what you need to do is that, okay, this can be cancelled out because u over 5 is 5, so we can cancel out it. So what's left is that this will become 1 over u. Our 5x is u, so this will become u squared minus 2 squared square root du. And final answer we can write it down to be, okay, 1 over 2 second arc secant. So this is going to be x, okay, x over I straight away write down the answer, sorry guys. So this should be not x, yeah, since you are dealing with u, so it will become arc secant u, right, u over 2 plus c. Right, so our u just now is 5x, so just copy it, half arc secant 5x divided by 2 plus c. Basically you can see that 1 over a is our 2 here, second 5x is 5x here, our x is you cannot straight away use it. It's actually 5x, so 5x over 2. All right. Okay, now we move to example 4.12. Example 4.12 is a quite special case because this function here, there's no or nothing that is very similar to the formula here. Yeah. So this is up until this, yeah, our inverse trigonometry. Down here is for the inverse hyper. So back to this question. So what you need to do is that you need to do special technique called completing the square. You might probably forgot about it, but here is the shortcut way to how to do this. Why you need to do completing the square technique is because for this quadratic functions, you cannot do the you cannot factorize it to become x plus whatever or minus whatever times x plus. So that algebraic expressions, you cannot get it, so you need to do the completing the square technique. So how to use it? So this is the given formula that you need to understand how to use this. So let me show you how to do that. Okay, so we have x squared minus 4x plus 13. So the coefficient for the x squared here, a, is equals to 1. So the coefficient for x here, b, is minus 4. Okay, and the coefficient for x power of 0, okay, is c, which is 13. So from here we can substitute into the completing square formula. Okay, so that, let me copy this one first. This is the formula for it, for the completing square technique. So x plus, so our b is minus 4, so minus 4 divided by 2, okay, squared, plus c is 13 minus b squared, so our b is minus 4 power of 2 over 4. So what you will get is x. So this is, you can simplify it, it will become minus 2. So x minus 2 squared plus, so if you solve this will become minus 4 squared is 16. So 16 divided by 4 is 4. So 13 minus 4, you will get what? You will get 9. So this is the denominator, the new denominator, which is equivalent to the original question here. Okay, now let's proceed. So when you want to integrate this one, it will become x minus 2 squared plus 9 dx. So now we look again, we refer to this table, the closest one, okay, the closest one is, yeah, this one, arctangent. So arctangent 1 divided by a squared plus x squared dx here. So we know that, okay, we know that we need to substitute it with u equals to x minus 2, therefore our du equals to dx. Okay, so you simply substitute it with u squared plus 9 du, and then you plug in you refer to the table here, arctangent, okay, 1 over a, arctangent x over a plus c. So let me copy that first. 1 over, so we have 1 over u arctangent, okay, u over a plus c, and our a, okay, our a, we've got 9 here, so 9 is actually okay, I forgot about this one, sorry. So it should be in the form of the original formula here, which is if I can write down, 1 over a squared plus x squared. Okay, so original question is 9, so 9 is 3 squared. So back to this, we have here 1 over u, so our u, okay, sorry, this is not yeah, it's not u, sorry, okay, this is 1 over a, sorry again guys, and this is x is our u, this is a, like, yeah, it gets confused even to me. Okay, so 1 over 3 arctangent u over 3 plus c, so our u is arctangent, u is x minus 2 over 3 plus c. So this is the final solution for example 4.12. So just remember that I think that's wrap up our final subchapter that we need to learn throughout this semester. And don't forget to finish up all exercises, even though I don't ask formally or request you guys to do that, but as a student you need to know that we need to do extra exercise, and that one including to do the exercise, all exercise in chapter 4.2 and 4.1. So good luck and all the best in your final examination.